So in this module, we'll take a look at virtual machines, storage, just to get an idea how those work in Azure. You know, if you're an IT pro and getting introduced to Azure administration, most often when you think about cloud computing and how I translate my infrastructure to cloud computing, you know, most administrators manage networks, VMs, and storage. So let's take a look at how those items translate into Azure. So within Azure, we have what are called Azure virtual machines. And these are very, very similar to the virtual machine that you would run on Hyper-V. In fact, you can take the virtual hard drives from a Hyper-V virtual machine and you can move them to Azure and vice versa. There's some work you've got to do to, you know, get them ready for transport, but for the most part, it's a pretty straightforward process. It allows you to run them only when you need them. The big difference between an Azure virtual machine and, for example, a Hyper-V virtual machine is with Azure VMs, you only pay for them when they're running. You only pay when they're running. So it's very economical, very simple, very easy to scale up and scale down. You can use a number of types of VMs, not just Windows VMs, also Linux VMs. The size of the VM is what's going to determine how many disks, how much network, how much memory, and the overall performance. So things like the total number of CPUs. You choose the size of the virtual machine, and that gives you a set number. For example, a small virtual machine might be 1 CPU, 4 gigs of RAM, and 2 disks. Whereas a large virtual machine might be 16 disks, 32 cores, 32 CPUs, and maybe 128 gigs of memory. Within Azure, you can change the size of the virtual machine at any time. So for example, we talk about, you know, the ability to scale up and scale down. I can begin, you know, if I go back to my accounting example, I can begin the year on a small virtual machine, and then when tax season comes around and my applications are very busy, go to a larger size virtual machine to scale up my capacity. You pay only for what you use, typically down to the minute. And then finally, you can have resiliency within virtual machines. If there's a hardware failure, it's automatically moved to a new location that's healthy and ready to go. And you can also establish clusters of virtual machines with fault tolerance. So if one goes down, the other one stays online. Storage. So, you know, where do my disks come from in Azure? Well, in Azure, it's a little bit different. You still have the notion of storage, but you have what's called an Azure storage account. Within the Azure storage account, you can create 4 basic things: blobs, queues, tables, and file services. Now, it's important to understand the difference. And the first question that, you know, a new Azure administrator often asks is, well, what's a blob? Blob stands for binary large object. In other words, it's a catch-all. You can throw anything in a blob, and as long as the thing that's accessing it understands what it is, you're fine. Queues store messages that are being passed through applications. Tables is a very rudimentary style of database. In fact, calling it a database is probably a bad thing to do. It's a very rudimentary table-focused data store. So if all you need to do is store, you know, name, address, phone number, you can use an Azure storage table to do that versus getting into, you know, an Azure database. And then file services allow you to create a file share. So if you have servers that are running in Azure, you don't need to create a file server just to store files. You can create a storage account with a file services entry in the storage account, and it emulates a standard Windows SMB file server. Only the data, only you, the account owner, can access the data. You can govern permission. And there are 2 types of storage: standard storage and premium storage. We'll talk more about premium storage in a little bit. Standard storage is what most things are stored on. Premium storage is where virtual machines store their VHD files. So what you'll find on there are the VHD files that are used by virtual machines. So we talked about blob containers and what they are. All blobs must be inside a container, and a container you can loosely think of as a directory or as a folder. When you create a storage account, you want to put files in that storage account, you create a container. And within the container, you create blobs, and within the blob, you can now store things like VHD files. And we mentioned premium storage. Premium storage is only available for virtual machines. very high bandwidth, very low latency. This is, the best storage hardware that's available within Azure. Up to 32 terabytes per VM, up to 64,000 IOPS per VM, and 50,000 IOPS per disk with incredibly low storage latency. Now, if you're running a VM, obviously, you don't want storage to be an issue, especially performance, and so that's what premium storage is. You pay a little more for it, and only certain types of virtual machines make premium storage available. And as you're building and configuring your VMs, and we'll see this in other courses, when you choose the VM size, it will indicate whether or not that's on premium storage. And if this particular VM, if disk I/O is going to be a consideration, for example, it's a database VM, you obviously would want to go with premium storage.
Storage is really a huge topic when it comes to Azure. We have trillions and trillions of objects that are currently stored in Azure today around the world throughout our Azure data center regions. And storage has been designed, very durable, very scalable for large, even multi-petabyte storage needs that applications have within the cloud. Lots of customers using storage. Is probably one of the most common workloads, I would say, that people use Azure for. Is if they don't know, if they're not using it for anything else, chances are they're using it at least for storage. Would you agree with that?
Yeah, definitely. I mean, the price for storage has gone down so much in the past years. So, I mean, everyone is looking for better and cheaper ways to store their data and more efficient ways, really.
Yep, definitely. And one of the areas, though, that I find some confusion around for other cloud professionals that are coming from competing cloud platforms, like maybe they have a lot of experience with AWS, for instance, and they're looking at Azure storage, is on the Azure side, we kind of combine things a little differently than some of the other cloud providers do, where we have really two Uber storage offerings. We have Azure Standard Storage and then Azure Premium Storage. And within Azure Standard Storage, we have lots of different options for how storage can be provided, right? We've got standard storage that can provide blobs as objects. We've got Azure Files that provide more of a cloud-driven file share service. We've got table storage as part of Azure Standard Storage. We've got queues, and then we've got disks, where standard storage can even provide magnetic back disks. Standard storage encompasses all of those different storage offerings. You build a standard storage account, and then inside that standard storage account, you have different endpoints that you can use for blob object storage, for file storage, for queue storage, for table storage, and whatnot. And then when we think about faster, high IOPS type disk performance, we also have another type of storage, premium storage, that's SSD based, where premium storage is specific block storage that can be used to provide SSD backed virtual disks to virtual machines, making it highly scalable. And as we mentioned, storage is kind of the table stakes, right? In the cloud, everybody uses at least storage. So storage is pervasively available through any of our Azure data center regions. And as we mentioned, it's durable and highly available. And part of that durability is that when we think about standard storage, and storage is certainly durable and highly available across all of those regions. And part of that durability is baked right into the basis for our standard and premium storage, where as those storage services are presented within an Azure data center region and customers start writing their data to it, every block of data is synchronously triple written to 3 separate physical fault domains within a storage stamp in the Azure data center region to eliminate single points of failure, interrupting any access to storage. So very, very durable. In the event of failure within one fault domain, there's 2 other copies that are synchronously written and automatically can be used for servicing read and write requests, while a replacement copy of that 3rd copy is being generated on the fly behind the scenes. So very survivable. Beyond a single data center region, though, we also, just with A quick option choice when we're provisioning a storage account can enable a storage account for asynchronous geo-replicated storage, which goes even further. With geo-replicated storage, not only do we get the 3 synchronous copies in our local Azure data center region that we provision the storage account in, but we have 3 additional copies that are asynchronously replicated to a remote Azure data center region hundreds of miles away. So in the event of a big disaster and that primary data center region becomes unavailable for whatever reason, your data is safely being replicated over to that remote location. So kind of built-in data protection for disaster recovery purposes from that standpoint. So very durable, very available, storage, very scalable, as we said, into the range of petabytes of storage from that standpoint. One of the questions that I get a lot of times, though, is how the standard storage works with virtual machines, because virtual machines, when they're consuming standard storage, they don't normally consume it as blobs or tables or queues. They consume it normally as disks, right? And so one of the features of standard storage in our blob storage service is the ability to have a special type of blob called a page blob that can be exposed to a VM as what appears to be a block level magnetic backed disk device. And so our standard storage has the ability to also surface up these page blobs as virtual hard disks. Each of those can be up to a terabyte in size, and if you need more than a terabyte of space, you can stripe multiple disks together to create larger virtual file systems. Using our largest VM sizes, our G-series VMs, you can have up to 64 terabytes of total space, which is a ton of space per VM. And each of those underlying disks on standard storage can support up to 500 IOPS. So you can scale and stripe across multiple disks if you need more capacity or you need more IOPS. And this is all mag disk based, right? So we haven't talked about the SSD options yet for even higher performance. So when we're presenting these virtual disks then back to a VM, a lot of people ask, well, how exactly does that look from the VM standpoint? You know, the VM boots, and it's got, if it's a Windows VM, it's got a C drive. If it's a Linux VM, it's got a root file system as its OS disk, essentially. And that's stored as a page blob in Azure Blob Storage. And it's got a local host-level disk cache to be able to cache frequently accessed data, reads and writes locally. The VM also gets a local temporary disk that for a Windows VM gets exposed as a D drive. For a Linux VM is sort of a scratch file system, right? And that temporary storage is not persistently backed to Azure Blob Storage. It's really intended more for temporary needs while the VM is running. Things like a page file, swap area, temporary locations for building or indexing data, but nothing that you'd want to store persistently to this, because it's not blind. That VM, if that VM gets reprovisioned, this temporary disk gets regenerated on whatever host in the Azure region it's placed on. So don't put any data that you want to keep around on the temporary disk. Instead, you want to attach one or more additional data disks to that VM. Those data disks are each persistently backed by Azure Blob Storage as well as page blobs. So any data that you write to them is persistent across the lifetime of that disk. So the VM shuts down, restarts, gets reprovisioned, the disks can be pulled back in, the data is retained. So in Azure, it could be that you're shutting down the VM and deleting it, but keeping the disks around. Or it could be in Azure that you're just shutting down the VM into what we call a deallocated state. And then in that deallocated state, the VM is not reserving any CPU or memory or IP address type resources. And so there's no cost for the compute charges of the VM on Azure when it's in that deallocated state. But even in that deallocated state, all of the data that you've written to persistent disks is still safely stored out to Azure Blob Storage. And then when you start the VM back up again, it reprovisions it and ties it back to those same disks it was using previously and has access to all the same data.
Cool.
Great. Now, in addition to presenting block-level storage as virtual hard disks, with Azure, we also have the ability to present storage as a file share through right from our Azure standard storage through an endpoint called Azure Files, a service of standard storage called Azure Files. Azure Files provides an SMB3 or CIFS accessible location that sits right on top of the Azure storage account. So you don't have to spin up any VMs to be file servers or anything of that nature. It's just an alternate protocol to expose Azure storage accounts through. So it's great for things like web applications that might need a shared location across multiple VMs for storing things like configuration or common content or diagnostic logs or whatnot. We see a lot of customers that use this approach for lifting and shifting web applications up to Azure, where those web applications might be pointing to a CIFS or an SMB share for reading and writing a lot of that information back. So it's a great option from that standpoint. And when we use that Azure Files mount point, essentially inside the VM, it gets mounted as what looks like another native mount location for that VM. So if it's a Windows VM, it can be mapped to like a network location and give a network drive letter to, like a G: or H: drive letter, for instance, inside the VM. Or if it's a Linux VM, it could be mounted in at the FS tab as a CIFS share and show up as whatever mount point that you've mounted that location under. So very flexible from that standpoint. The last area that we want to talk about, though, from a storage standpoint is premium storage. Premium storage is our SSD-based offering. So it's similar for those, and each of those disks can support up to 5,000 IOPS per disk. You can scale up to multiple disks per VM with our largest VMs. You can scale up to 64 provisioned storage disks, reaching up to 64 terabytes of total storage and as much as 80,000 or more IOPS. The premium storage disks are intended to be used with a specific class of Azure VM instances that you'll see when you're provisioning VMs. It's the DS and GS series VMs. The S in both of those cases stands for SSD. So it's a D series or a G series VM that has high-speed connectivity back to our premium storage stamps within that same Azure data center region. So when you need heavy-duty throughput, that's where you can go. Well, Gerald, we've been talking quite a bit about storage. Do you think it makes sense to drop over into the portal and take a look at the CLI and some templates around setting storage up?
Yeah, I think so.
Okay. Well, why don't we head over to the lab and we'll drop in and build our storage accounts together and see how that looks. So we're going to step through in the Azure portal first, building out a new storage account, and then we'll look at storage accounts through the CLI as well and look at how we can interact with them more programmatically. So in the Azure portal, I can provision a new storage account just like any other resource by clicking on New, and then under Data and Storage, I can select Storage Account. So you'll see that listed here. And when I select Storage Account, it's going to prompt me for some basic parameters. So I need to give each storage account a unique name. So let's see, I'll call this Contoso Store 05, we'll say. And it'll just check to make sure that that is indeed a unique name. And then it's going to ask me for a kind of account. This is a relatively new feature. We've got two choices here, general purpose or blob storage. General purpose allows me to build a storage account that provides all of the facilities that we've been talking about so far, whereas blob storage builds a special purpose storage account that I have the ability to activate for cool storage or hot storage. So recently we announced our cool storage offering that's at a much lower price point per gigabyte for data that's infrequently accessed. Still has the same durability and general performance characteristics, but the expectation is that that data would not be as frequently accessed, so it wouldn't place as much of a load on our storage stamp, and because of that, we pass that savings on to our customers as well. So a great option in cool storage for longer-term archival storage. Whereas if we, for our account kind, if we choose general purpose, we don't get that access tier option for cool versus hot, and it assumes that the storage account is going to be using hot storage for everything with general purpose. With general purpose, I'm sorry, go ahead, Gerald.
And for one of the things for cool storage, I just want to let folks know is the big difference is, even though you are saving the cost, when you do read, let's say that you were to use cool storage and you were reading a lot, then you pay more for those reads. That is the difference. That's where the cost really comes back at you. So it's something to just keep in mind and be aware of when you can actually move from the cool to the hot storage and move back down as appropriate, but you just need to make sure that you know where your assets are. And we have helpful tools to actually, monitor those scenarios for you.
Yep, that's a great point. So we'll create a hot storage account, and I'm going to create it as a general purpose storage account so that we can use disks or blobs or tables or queues or any of that. And the next question is going to ask me is, do I want a standard storage account that has all of those storage features that we talked about earlier, the blob objects and tables and queues and Azure files, and the ability to create magnetically backed block storage through page blobs? Or do I specifically want the SSD-based premium storage for VMs that have very heavy-duty storage needs? So I'll select standard, and under standard you'll also see our various replication options. So a little earlier we talked about local redundancy for standard and premium storage within an Azure data center region, where every write is synchronously copied to 3 separate fault domains for standard and premium storage. With standard storage, we also have those geo-replication options to replicate to a remote geo-redundant Azure data center region, or to replicate to that remote Azure data center region and have read access to that replicated copy. So that if our application wanted to balance read requests between a couple data centers, it could. We also have an option for zone redundant storage. That's more for blob storage, object storage in our Azure Standard Storage Service, and that creates a it creates a replicated copy of the storage in multiple zones within an Azure data center region. So you have all of those options available to you based on how protected you want that storage to be. The normal criteria is if we're using an Azure storage account for storing objects like block blobs, storing queues, storing tables or whatnot, usually we'd select either geo-redundant or read access geo-redundant. If we're using the storage account for virtual hard disks, particularly virtual hard disks that have very high levels of IOP requirements, we'd want to use locally redundant storage, because then we don't have to worry about the extra overhead of geo-replicating that data. And then generally from a VM standpoint, we would store images or backup copies of those VMs in a separate geo-replicated storage account. Storage accounts that have sort of a quota up to 500 terabytes per standard storage account. And you're absolutely right. We have lots of customers that are storing petabytes and petabytes of data. We have lots of good patterns on our available for customers that are storing high volumes of data, for being able to manage that data across multiple storage accounts. And absolutely, the storage account quotas have been put in place to really be able to provide assurance for performance and scale and SLA availability across those storage accounts. Yep, definitely. So very good point. Consideration to keep in mind. So we fill out the basic properties of our storage account. I'm just going to finish up selecting our subscription, selecting our resource group. So I'll select an existing resource group to pop this inside, and then click Create. And that'll go ahead and create that storage account for me. And once that's created, I can navigate into the properties of that storage account. We'll see the deployment started, and it should be created in just a few moments. And our storage account deployment has succeeded. So just like we saw in episode 2 for networking, we can search for that storage account over in our browse area and pull it up through our resource group, or we can just go ahead and search for it. So I'm just going to do a global search and look for our storage account. So I'll say Contoso Store. There we go. Contoso Store '05 was the one we just created. And then within the properties of that storage account, once that comes up, we'll see all of the various services that we talked about for standard storage. So blobs, encompassing both block blob objects as well as page blobs for magnetic disks, file storage, tables, queues, all centrally provisionable, configurable right from our storage account. So we looked at a little bit at the portal for provisioning and managing storage accounts. Let's drop over into our CLI and take a look at how we might be able to manage storage from over there. And the Azure CLI, the cross-platform CLI for Linux, Mac OS X, and Windows, provides us with a whole raft of Azure storage commands. And so if I just type Azure Storage with a -- help switch, we'll see all of those commands for managing all the various aspects of Azure storage consistently across tables and queues and file shares and directories, be able to create and manage blobs, containers to organize my blobs, and storage accounts, which we just created through the portal. And so sure enough, if I, in my CLI, if I do an Azure storage account list, we'll see a list of all the storage accounts across my subscription for all the Azure data center regions. Here's the new storage account that I just created. And you'll see in the SKU name whether they're premium storage or standard storage and whether they're locally replicated or geo-replicated. So you can see I've got a premium storage account and then several standard storage accounts as well, distributed across all of my various Azure data center regions. So to create a new storage account, I can just do an Azure storage account create and then just specify the basic properties. So I need to give my new storage account a name. So we'll say this is Contoso Store 06. I need to specify which resource group I'd like to place that storage account within. So we'll say Contoso RG, just like before. And I need to tell it what type of storage account. So for my SKU name, I want it to be geo-replicated, just like we did through the portal. And I want it to be in the same location that we've been using in our Southeast Asia data center region. And for the kind, we're just going to make it standard storage. So let me just clear the screen and we'll create a new storage account here. So I'll just do an Azure storage account create and I'll give our storage account a new name. So we'll say this is Contoso Store 06 and we'll give it tell it which resource group we wish it to be in. So Contoso RG. We'll specify what type of storage it is, whether it's locally replicated or geo-replicated. I'll make this geo-replicated. And which location, so I'll say it's Southeast Asia for the location. And then the kind, so we'll just say it's standard storage. So I'll go ahead and press enter, and assuming that I didn't fat finger anything, it'll go through and create my new storage account, just like I did through the portal.
This is the first video in a 3-part series that helps you get started with Microsoft Azure Backup. Azure Backup is a simple and powerful service that empowers customers to back up Microsoft workloads to Azure. This series will help you back up Windows servers to Azure. This video will help you set up a backup vault on Azure Management Portal. This video will also help you download the required files from the Azure Management Portal to prepare your production workloads. You need an Azure subscription to follow the instructions in this video. If you don't have one, the easiest way to acquire an Azure subscription is with a free trial. Azure has a free trial that lets customers try Azure services for a limited period of time. If you're new to Azure and would like to make use of this offer, click on the Try for Free on Azure page and follow the instructions. It's incredibly easy to start using Azure Backup once you have an Azure subscription. To begin, navigate to the Azure Management Portal. On the left side, you'll see a list of all Azure services. Azure Backup is a part of Recovery Services. Navigate to the service. You need to create a vault to get started with Recovery Services. A vault is like a virtual container. Protected servers are associated with these containers or vaults. To start using Azure Backup, you will need a backup vault. When creating a vault, you need to select a region. We've seen that many customers pick a region that's far away. This is because they want their off-site backups to Azure to be far away from their production servers. This is unnecessary. Azure Backup automatically geo-replicates backup data to a secondary data center. Hence, the best approach is to select a region that's close to your production servers. This ensures fast data transfers. Give the vault a recognizable name. In this demo, the account I am signed in has a single Azure subscription associated with it. If you are managing multiple subscriptions, make sure you select the right subscription for the vault. Once you've created the vault, navigate to the vault. You will need to download 2 files to your on-premise server from this page to back up the server to this vault. They are the Vault Credentials file and the Azure Backup Agent installer. The Vault Credentials file will act as an authentication file that's used to authorize the production server during the registration process. The Vault Credentials file contains a key. It's highly recommended that you safeguard the downloaded file. For security reasons, the key in the file expires after 48 hours. Make sure that you register your server before this time comes to pass. Agent downloads are offered in 2 versions. One for Windows Server Essentials SKU, the other for all other Windows Server SKUs and System Center Data Protection Manager. You'll need to download appropriate agent binaries and Vault Credentials file from this page to proceed. This video will help you with installation of Azure Backup Agent on your production server and registering it with a backup vault. A backup vault on Azure Management Portal is a prerequisite for this video. You also need to have downloaded the Azure Backup Agent and the Vault Credentials file from the Azure Management Portal. If you haven't done so, please follow the instructions in the previous video to get these files. To begin, execute the Azure Backup Agent installer. You need to select a location for the agent to be installed in and a location to serve as cache for Azure Backup Agent. It is recommended that at least 10% of the data that will be backed up from this production server be allowed as cache space for optimal performance of Azure Backup. In the next screen, you are required to enter proxy settings. If you are behind an authenticated proxy, it's possible that internet connectivity is available through Internet Explorer, but registration of Recovery Services Agent fails if you forget to enter proxy details. Make sure that you enter the correct proxy details here. In the next screen, Installer checks for and installs some prerequisites such as .NET Framework and Windows PowerShell. Once these are in place, you are able to proceed seamlessly. Critical updates to Azure Backup are made available through Microsoft Updates, and it's highly recommended that you opt into this service if you haven't already done so. Once the installer completes installation, you can proceed to registration by clicking on the Proceed to Register button. In this screen, you need to provide the installer with the Vault Credentials file. If you don't have this file, please follow the instructions in the previous video to download it. You can now review the Vault Credentials details and proceed to the next screen. The encryption settings screen will ask you to provide a passphrase. This passphrase is used to encrypt your data in transit and at rest in Microsoft Azure. In case you lose this key, backup data cannot be retrieved. Note that Microsoft has no knowledge of this key and you are the sole owner of this key. It's highly recommended that you save the passphrase to a file and secure it in an off-site location. Once you've entered encryption settings, you are able to finish installation of the Azure Backup Agent. This video will demonstrate backing up and restoring files and folders from a Windows server to Microsoft Azure. You need to have installed the Recovery Services Agent on your production server and registered it with a vault in Azure to get started. If you haven't done so, please follow the instructions in the previous video. To begin, launch the Azure Backup Snap-in. In the app, you need to configure the backup policy by selecting items to be backed up, specifying the frequency to back it up, and finally scheduling these backups. To do so, begin by clicking the Schedule Backup button. The first screen has information on getting started. If this is the first time you are using the service, I recommend that you take the time to read this. In the next screen, you will select items that you want to protect. You can choose as many or as few files and folders or volumes you want to backup. The Specify Backup screen is an important one. This screen is where you set the synchronization frequency, that is to say, when and how often backups are taken, and the retention policy, that is to say, how long the backups are preserved. This affords a great deal of flexibility, and you can enter these parameters to match your requirements. Once you have entered this information, on the confirmation screen, you're able to review all the information you have entered. Once you confirm, you're able to finish the wizard and start backing up data on your production server to Azure. Now that you've scheduled a job, it will run at specified time and back up your production data. Let us now look at a workflow to recover the data. To begin, click on the Recover Data button. This will launch the Recover Data wizard. The first screen asks you to identify the server on which the backup was created. In this demonstration, the files are being recovered were originally backed up on this server. In the next screen, you are afforded a recovery mode. Select the Browse mode if you know exactly where the files and folders you're trying to restore are located. The Search mode will help you search for files within the backup. This is useful when you do not know the exact location of the file that you're trying to recover. In this demonstration, we will use the Browse mode. In the next screen, you will begin by selecting a volume. If you have multiple volumes being backed up, you can run Recovery Wizard on one volume at a time. You'll need to select the date and time next. This affords you the flexibility to recover the exact version of the file or folder you're trying to restore if you have multiple copies of the files and folders in your backup history. In the next screen, you will select items for recovery. The Search for File workflow would have allowed you to search for a file or folder in this screen. You can select the files and folders or entire volume as per your need to restore. In this demonstration, the one file that was backed up will be recovered. In the next screen, you will need to select the location where you want to restore the file to. You have an option of restoring it to the original location, that is the location from which the original backup was taken, or restoring it to another location of your choice. In case a file of the same name exists in the recovery destination, you have an option of overwriting, creating a copy, or not recovering the file at all. Furthermore, you have an option of restoring the permissions set on the originally backed up files or folders. Once all the details are entered, recovery operation can be initiated by clicking on the Recover button. This is the end of this demonstration.
Hello, I'm Shrish Dubey, Principal Group Program Manager at Microsoft. In this video, I will give you a brief overview of Microsoft Azure Backup Server, a project we internally call Venus that was made generally available on October 7, 2015. When we released Azure Backup Service, we provided protection for files and folders, which allowed customers to protect their on-premises files and folders to Azure, either for off-site storage, compliance, or long-term retention. As the service grew, we started getting requests for protecting business workload data such as SQL, Exchange, SharePoint, and Hyper-V. Our response initially was to deploy System Center Protection Manager for this use case. This required a suite license for System Center, which worked fine for enterprise customers, but was not an economically viable option for most SMB customers. So we developed Microsoft Azure Backup Server with the SMB segment in mind. It is functionally equivalent to System Center DPM with three differences. It has no System Center integration features such as VM discovery and Central Console for reporting, monitoring, and alerting. It has no support for tapes. It requires an active Azure subscription. Microsoft Azure Backup Server provides full fidelity workload support and can protect them whether they're running on Hyper-V, VMware, or physical servers. It supports all key Microsoft workloads such as SQL, Exchange, SharePoint, Hyper-V, as well as infrastructure workloads like IIS, AD, and DNS. We continue to enhance the list of platforms and workloads we support in Microsoft Azure Backup Server. Furthermore, we intend to maintain feature parity between Microsoft Azure Backup Server and System Center DPM other than the three differences mentioned earlier. Now let me talk about the hybrid cloud backup scenario enabled by Microsoft Azure Backup Server. First is the need for an on-premise backup copy. RTO requirements for workload backup are much tighter where data needs to be restored within minutes, which is not feasible with a cloud backup copy. Therefore, Microsoft Azure Backup Server provides full support for an on-premise backup copy. Optionally, you can also use it for a copy in Azure. The data sent to Azure is encrypted before it is sent to the cloud, sent over the wire on HTTPS, and stored encrypted in Azure Backup Vault. The cloud copy can have a retention policy with full GFS support, grandfather, father, son, that is required for compliance scenarios. In summary, Microsoft Azure Backup Server provides an end-to-end backup solution for workload protection. You can download Microsoft Azure Backup Server from the same place where you update your agents for Azure Backup. This is the initial screen you get to when you navigate from the Backup Vault in your Azure subscription. Since this download is a bit more involved than an agent download, we have created two videos to help you download, install, register, and configure Microsoft Azure Backup Server and encourage you to watch them to get it up and running. Microsoft Azure Backup is available as a free download with your Azure Backup subscription, and the pricing model is the same as Azure Backup, which is protected instance fee plus storage consumed in Azure, either GRS or LRS. Microsoft Azure Backup Server also includes SQL Server, which can be used in the context of the Azure Backup Service. One important point to note: although the primary use case for Microsoft Azure Backup Server is hybrid backup, where you have a local disk backup and an offsite backup in Azure, you can use Microsoft Azure Backup Server exclusively for local disk backup only. It costs the same in terms of instance pricing, but you will not be charged for storage as you're not using Azure for the offsite backup copy.